Section 7-2 is about similar polygons, which continues nicely from our last discussion about ratios and proportions, because similar polygons are proportional and they have some common ratios. Okay, so let's look at some similar polygons. Here I have two trapezoids, and they're similar. That's what this symbol right here means. It's like the congruent symbol, but not being equal. Okay, so trapezoid ABCD is similar to trapezoid GHIJ. Okay, what that means is the corresponding angles are congruent. So angle A and G are congruent, angles B and H are congruent, angles C and I are congruent, angle D and J are congruent. Okay, but not only that, the corresponding sides are proportional, not congruent, but proportional. So if I look at AB over GH, that ratio is the same as BC over HI, which would be the same as the ratio of CD to IJ, which is the same as AD to GJ. Okay, let me give you some numbers just to show you what that looks like. If this length was 4, and this was 5, and this was also 5, and this was 7, and this was 8, and this was 10, and this was 10, and this was 14, then the ratio of AB to GH would be 4 to 8. And that would be the same as BC to HI, or 5 to 10. Okay, CD to IJ is also 5 to 10. And AD to GJ is 7 to 14. Okay, so all these ratios are equal to 1/2. Okay, and 1/2 is an important number. It's called the scale factor. We'll get into that a little bit later. But the corresponding angles are congruent and the corresponding sides are proportional. Okay, are these polygons similar? Okay, and if they are, write a similarity statement and give the scale factor. Now looking at these two rectangles, it's pretty clear that the ratio of, if I thought of these as corresponding sides, it wouldn't work because 15 and 15 are the same and 10 and 20 are different. But if I thought about taking this one and turning it on its side, so I think about 15 to 20 as corresponding sides and 10 to 15 as corresponding sides, that might work. So I'll look at the ratio of 15 to 20, and I'll compare that to 10 to 15. Now 15 over 20 is 0.75, and is that equal to 10 over 15, which is 0.66? Well, no, they're not the same. And so these two rectangles are not similar. Okay? Even though they have congruent corresponding angles, their sides are not proportional. Let's look at B. I'll just take 18 to 9 and compare that to 12 to 6. Well, 18 over 9 is 2, and 12 over 6 is 2, and so they are equal. Okay? And the number is 2. So we'll look at that number. 18 over 9 is 2, 18 over 9 is 2, and 12 over 6 is 2. Okay? So they all have the same ratio, okay, the same scale factor, and so these two pentagons are similar. So my similarity statement is A, B, C, D, E is similar to, make sure the order is the same, S, R, V, U, T. And the scale factor is 2. Okay, and that'll wrap up our first video on what does it mean for polygons to be similar. In this second video on section 7-2, we'll look at finding missing side lengths. Okay, and before we do, I want to talk briefly about the different kinds of ratios that we could use and how we could use the scale factor to do this. Okay, we've already talked in the first video about corresponding ratios. Okay, for example, the fact that 2 over 4 is equal to 5 over 10 is equal to 9 over 18. Okay, and all you would need to do is put in the place of one of those lengths, the missing length, for example, x or y or whatever the variable may be. Okay. Another ratio you could use and you could look at was, for example, 5 over 2 is equal to 10 over 4. Okay, now that's a kind of a ratio kind of inside or within each figure. Or you could look at 9 over 5 is equal to 18 over 10. Okay, now I call this an internal ratio. I'm not sure if that's the true mathematical name or if there is a true mathematical name, but that's what I think of it as. Okay, so you could use either one of those ratios to find missing side lengths. Okay, one more way that you could do it, which is a pretty common way, is by using the scale factor. Okay, now the scale factor you would get from the corresponding ratio is 1/2. Okay, so any length in this triangle, if I multiplied it by 1/2, I would get the length in this triangle. So I take 18 times 1/2 is 9. 10 times 1/2 is 5. Okay, and similarly, you can either to go from this triangle back to this triangle, you can either multiply by the reciprocal, which in this case is multiplying by 2, or you can take the same scale factor 1/2 and just divide by that scale factor. Okay, so I could take 2, divide by 1/2 and get 4. Okay, now in this, now dividing by a fraction may be kind of confusing to some of you, but that's a way of doing it. Okay, let's look at a problem. These quadrilaterals are similar. Find the values of each variable. Okay, now I'm personally going to use corresponding ratios. I think that's the simplest way to do it. And I'm first going to find x. Okay, now x corresponds with 12. And so I'll set up the proportion x over 12 is equal to, now I will look for a ratio between these two or two corresponding sides that I know. Okay, and I know 6 and 9. Okay, now before I put 6 and 9 up there, let me think really quickly about the ratio that I just wrote, x over 12. I'm relating the smaller side to the bigger side. Okay, so it's important that I keep that consistent. Okay, so with 6 and 9, I will keep the 6 from the smaller polygon to 9, the larger polygon. Okay, and that gives me the ratio of what I need to use. So I will simply solve this proportion. I will cross multiply. X times 9 is 9x. 6 times 12 is 72. Divide both sides by 9, and x is equal to 8. Okay. Similarly, I will find y. Now y corresponds with 6. Okay, so I will look at the ratio of y over 6. Now keep in mind the ratio that I just wrote. This ratio now is the bigger over the smaller. Okay, so y over 6 will be equal to, I can use the same ratio that I know, is equal to 9 over 6. Okay, now if you're smart, you can look and say, well, these numbers are the same, and so these numbers must be the same. Okay, so y must be equal to 9. Now, if you want to cross multiply instead and say, you know, y times 6 is 6y, and 9 times 6 is 54, divide both sides by 6, y is equal to 9. Okay, you get the same thing. All right, now the last one we'll find is z, and again I will put z over 3.5, and again I'm looking at a big over small ratio, so I will use 9 and 6 as a big over small and solve that proportion. Okay, for the sake of time I won't actually solve that one.